Okay, it's 10 past. I think we will make a start. My name is Kevin Stratford, and I'm running this what is a 1.5 day course, which is an introduction to ARCHER2 for software developers. I should point out that we're recording the transmission for future reference. So I'll just perhaps at the start say we have some helpers today who are Julian. Don't know if you want to say hello, Julian.
Hey everyone.
And Quevin. Quevin might be slightly distracted just at the moment, but Quevin's also helping out today.
Hello.
Ah, there you are. Good. So if you've got a problem, these guys will be watching the chat and will jump in and try to help you out if I am just talking to the material. So what's the idea of the course and what's the timetable? So the idea of the course is to provide an introduction for software developers. Okay, so what is a software developer in this context? Well, someone who may be interested in at least compiling and perhaps even writing their own code on Archer, and this is in distinction to a slightly separate course we run, which is aimed more at people who just want to use the service to do production work and don't particularly care about code so much. But certainly there's a good deal of content which is common to all these activities, whichever programming model you're interested in. So the kind of things we're interested in is what does ARCHER2 look like? So again, as a matter of interest, by show of hands, is there anybody who is not a current Archer user? Yeah, one. Okay, so the core, yeah, so that's fine. If you have used ARCHER1, a lot of this should be looking moderately familiar, but there are significant differences. If you haven't used ARCHER1, don't worry. Hopefully, this will be a self-contained introduction in itself. So how do we get access interactively and so forth and transfer data? What does the application development environment look like in terms of what's available and how to use it? The important question of how to write a job submission script and submit them to the scheduler. So there's a fairly significant difference between ARCHER1 and ARCHER2 in that context. We'll have a bit of a look at issues such as debugging and profiling, and also a few other subjects around being a good citizen here and how to use the safe to be able to check what resources you have and so forth. Okay, so we're expecting that everybody's obviously has a machine on their desk or whatever you're using for work, and that machine is going to allow you to log in and you are familiar with using SSH and so forth. There is a code of conduct, start that again, and a code of conduct there, if you wish to have a look at it. There are also some statements about accessibility, which we try to make sure this is accessible. Obviously, physical aspects of this are not relevant for many of us today, although I should say I am sitting in my office at work, so if the fire alarm goes off, I will have to evacuate, and I'll probably come back in about after half an hour of standing outside. But hopefully that will not happen today. So that's my email there if you want to contact me behind the scenes or for any reason. As I say, we're expecting, for the purposes of this course, you are familiar with the concepts of a high-performance computing facility and are familiar with using the command line and so forth. Okay, so here's the schedule. The first lecture is just a welcome with some extra words about what the course is about and how to give feedback. We'll spend a little time making sure everybody can connect and has an account and so forth. So don't worry if you're not quite there yet, we'll help you out. We'll try to keep more or less to the scheduled breaks, but if I'm overrunning, we may move the breaks a little, but we'll try and keep the breaks the same length. In the morning, we also have an overview of the ARCHER2 system in terms of what does it look like from the hardware point of view, and how does this affect me as someone who uses the system, and also the development environment, as I say, what compilers, tools and libraries are available, and how can I manage my work of development within this environment. Lunch should be approximately 1 p.m. to 2 p.m. After lunch, we'll come back, we'll have a look. There's quite a long section on the scheduler, which is different from that which we have on ARCHER1, and also depending on how we go today, there's debugging and profiling examples. So if my code is erroneous, how can I find out where the errors are? And profiling addresses the question of how efficient is my code, or if I have or think I have a performance problem, how can I get some information on where that performance problem may be. There are then just a couple of sections on some more management type issues, how one should be a responsible user of such a shared system, and how can you use SAFE, which is the web portal you've hopefully all managed to get an account on, to track things like usage. If you need access to licensed software, we'll address that. Depending on how we go today, we may finish a little bit early. Tomorrow morning, really, the agenda is perhaps not so set in stone, but tomorrow morning is really geared to giving you a chance to try out your own code or whatever you wish to do, and we'll be available to help you out if there are any problems. So that's the schedule. Any questions at that point? If you type a question into the chat, may just be if your hand is up from the previous question, you may want to remember to take it down. That may be the question. Okay, so will be a bit of flip-flopping between screens from me as we go along, but hopefully everybody will be able to get the hang of what's going on. So let's, without further ado, let's have a look at the welcome, which covers these questions. Just a word basically on the structure, if you like, of the course. Rather than a series of formal lectures and practical sessions, the course is taught following a software carpentry-like methodology, if you've come across that before. So the idea is to try to get everyone to just work through at more or less the same pace by actually doing the material using your account. So I will be typing into my shell over here, which is so I'm logged into my laptop over here, and I'll type my commands in there. And so the helpers will be there to assist you if you have any problems. In a physical setting, that may just mean raising your hand or shouting out. There is also, as well as the chat, in which you can just dump your questions or raise your hand to ask a question. We have a link to an Etherpad, which may be suitable for longer pieces of content. Julian, perhaps you could paste the link for the Etherpad into the chat, just so people have the link. The link to the Etherpad is also in the course page at the ARCHER2 website.
Yeah, I'll look.
Mm-hmm. The carpentry method places significant emphasis on feedback, so it's very useful for us to have meaningful feedback on where things are working and where things are not working and what might be missing and so forth. So if you do have anything to let us know, please do so by one route or another. Again, in the physical setting, there are some ways to do that. We might try a little feedback activity near one of the breaks, but we'll see how we go. As ever, there will be somebody after you for feedback at the end of the course. As I say, it is very useful for us to have this feedback, particularly at this early stage of the ARCHER2 service. Things are not set in stone, and even we are still feeling our way around to discover the best way to do things. So any ideas are always most welcome. Okay, so I think that's probably all to be said on that. Okay, next topic is connecting to ARCHER2 and transferring data. Okay, so here's the address, login.archer2, the all-important 2 in there, not to be confused with ARCHER1, and the security mechanism we use to authenticate to ARCHER2 is to use a combination of both a password and a passphrase protected SSH key pair. So in having signed up to SAFE, you should, as part of that process, have uploaded an SSH public key, which will form part of the authentication process. So when you first get an account, there will be an initial password associated with that machine account, which you must recover from the SAFE, the web portal. That initial password is usually some horrible long string of random letters and numbers. So when you'll log in, the first thing you will be asked to do is to change that initial password. And so the first piece of policy you will be confronted with is the password policy, which is here. So if we have a look at this link for ARCHER2 password policy, which is at the main ARCHER2 website, we see the policy is basically this. So there is a minimum length of 18 characters, which sounds alarmingly long. However, one basically gets a discount for adding complexity to the password. So if you use Lowercase characters, you get a discount of 2 characters. Uppercase characters give you another discount of 2 characters, and so on for adding numbers, numerical characters, and also punctuation or special characters. So basically there is a trade-off there between length and complexity, which you have to decide yourself on how you like to manage your passwords. Being old-fashioned, I still try to keep all my passwords in my head, which is becoming increasingly untenable, and you may wish to use password manager or so forth to help you with this process. So if at any point you ever have to change password again, there are some additional rules on saying basically the new password should be different, which hopefully fairly clear. So just as quick exercise here, which you can convince yourself you can work out the answer to. The exercise is to decide which of these following 4 passwords is valid in terms of the policy, but also there's a separate question about whether it is a good secure password. So have just a minute to think about that. You may need to refer to the policy. Okay, so hopefully this is not too problematic. Anybody think that is a good password? Good, move on. This one, how about this one? Rainbow llama jumping. Anybody think that is a good password? So I was listening to the radio the other day, and there was a member of staff from the UK Cyber Security Centre on there talking about how to choose a good password, and he was extolling the virtues of 3 random words. So here's an example of that. So while it's all lowercase, if you count up the letters there, it should be at least 18, so it should be 7, 12, 16, 19, so that should qualify, and that's a reasonable choice for a secure password, because it's unlikely anybody will come up with that combination. So this one might have to be looked slightly more closely. So that's an example of a more complex password. So is that one valid? Anybody think that one is valid? In terms of the policy. Okay, so this has what's it got? We've got some uppercase, we've got some lowercase, we've got some special characters, and we've got some numbers. So that should give us 8 characters of discount. So it needs to be at least 10 characters in total. So I think that one does would qualify as a decent password if you can remember it. Also this one. Depending on your knowledge of popular culture, you may say, looking at that, that's all lowercase. However, it's 3 apparently random words of sufficient length, but that may, while a valid choice according to the policy, it may not actually be a good choice in terms of security, because we are told here this is a well-known example from a popular web comic, which I believe is XKCD. So that would probably not be a wise choice of password. Okay, so hopefully that is all clear. As well as the password, we need SSH passphrase, and so when you generate your SSH public-private key pair, please do use a passphrase for that key pair. So I'm just going to run through this in case anybody is wondering what this looks like. So when you log in to SAFE, if you find the login accounts menu here, I've got quite a lot. I happen to know that today's my account that is associated with today's course is this one. So I can view my login account password by clicking that button there. So if I do that, I should now be able to log in. So I can do this. My account name for today is, I think I missed out the A in my account name. So hopefully everybody is able to do something like this. So SSH usually looks in a series of standard places to find public-private key pairs. So when you hit that, SSH will look in a standard location for key information, and that is usually this .ssh subdirectory in your home directory. So I have a few here. So here's my public and private key pair for ARCHER2 in this case. Notice the public key has the following file permissions, so it's read write for the owner, read for the group, and read for others. However, the private part, which is without the .pub extension, is private, as its name suggests. So only the owner has read permission. So if I was to use that key, I can specify a key explicitly to SSH. I'm going to have to put my account name again for this account. Oops. Okay, so okay, what's gone on there? Yeah, that's my classic mistake. Is not the login to the wrong system. So I need so ARCHER2. You asked for your machine password first, so I'm going to type this in carefully. Watch out for case sensitivity in the characters. I got that wrong. So the first thing, as I said, you will immediately be asked to change your machine password, which it is referring to as this LDAP password. So I'm going to type that initial password from safe again. Let's give me a good password today. Yeah, okay. You see, this is not always the easiest thing, especially typing live. Okay, good. I made progress. So I want to type in my new well-chosen password according to the policy. I need to type that twice. And finally, I need to put in my SSH passphrase. Hopefully, hooray, we've finally managed to log in. Good. So anybody still having problems with that? Hopefully the time it took me to do it everybody's got past that stage. Thank you. Yep, good, good. Yeah. Okay, so the first thing I'm going to do is log out again, like so, just to point out that some convenience can be added by setting up some config in your .ssh settings. So if we have a look at that, we'll see what I've got in there for ARCHER2. Okay, ARCHER2, let's have a look at this section down here. So if you can see, I've got a whole load of sections for various different machines here, and this is the settings for ARCHER2. So there's a series of special tokens that you're allowed to set in these SSH config. So there's one here which sets the private key if you have a non-standard name. This is my standard user account name is Kevin, so that's telling it the username. So this control section here is some special incantations which allows you to effectively authenticate once and use the existing connection to piggyback further connections. So this is quite useful if you, for example, want to do lots of S copies and don't want to have to retype the password all the time. So there is some special file associated with this, which is this control. Oops, let's not do that. This special control path, and this thing will also hang around for a certain number of seconds after I log out, and there are a number of other settings you can use. So if you're doing this config, SSH config is worth investigating if you log in on a frequent basis. Okay, so that's basically, hopefully everybody's managed to log in. So the first thing one may want to think about is moving some data in to the machine, which means using either a secure copy, SCP, or often rsync. Now, if you have a certain number of file and directory structure you want to synchronize between different locations. There's also, here's a question. Has anybody heard of Globus? And don't be, I would be moderately surprised if anybody has. So Don't worry about that. Okay, so the other point to note here, so SCP and rsync are standard mechanisms which you can use to move files from wherever into login.archer2.ac.uk. For those of you who are sitting on ARCHER1 at the moment, I should note that there will be some special routing in place to offer a high bandwidth between ARCHER1 and ARCHER2 when the time comes to transfer data. The mechanism will still be scopy or rsync. It will just involve a different host name, effectively, to which to direct your transfers, and information on that is available, and you should have a look when the time comes. Okay. How are we doing? So I think let's just have a look at this, how we're doing on the schedule. Let's just have a look. So I think 10:50 was the break, so we'll stick to the schedule and we'll restart, and I'll go over the data transfer at 11:20 restart. But if anybody's still having any problems logging in and so forth, please let us know. But otherwise, we'll restart at 11:20 and we'll continue with the data transfer. Okay, folks, welcome back. It's 20 past. So we'll make a start. Just to check, has everybody managed to log in? Or alternatively, is anybody still struggling to log in? Please do let us know, because we'll soon be requiring terminal access. Okay, so we just reached a few notes on good practice in terms of data transfer. So we've got our basic scopy or rsync methods available to do data transfer for us, but we should also spend a few seconds just thinking a little bit about which data we are going to transfer. So in all contexts, whether you're working as part of a team on a project or as a PhD student, or an independent researcher or whatever, you should know something about what data resources you have, and in an ideal world, if you have important data, one should even consider having a data management plan, and that will make you think about which data you need to preserve in the long term and so forth, and which are expendable. So in terms of if you need to keep data and therefore transfer it, there is actually a cost in both time and effort doing this. which it's good to think a little bit about. For example, the bandwidth between ARCHER1 and ARCHER2 might be something in the region of 50 to 100 gigabytes per second. So based on such a number, one may do a back of the envelope calculation to allow you to make an estimate of the time it's actually going to take you to transfer a certain amount of data. But beyond that, one should obviously try to minimize the quantity of data that is to be transferred. One also may wish to minimize the actual number of files which are transferred. So for every different file, there may be a small overhead involved. So if you have zillions of files, you should consider bundling these up into an archive, which is a single file, and then transfer that. You may want to think about data compression. If your data are already in some compressed format, there's probably not much point in trying to compress it again. If it is in a raw format, which is uncompressed, you may again wish to use something like zip or tar to compress it before transfer, and the saving can be significant. Again, one should realize that the compression of data actually takes effort, it takes time. So in some cases, time spent in compression may be an overhead in itself, which you may wish or not wish to take. So there may be some experimentation involved in these steps. Additionally, as their name suggests, things like secure copy are secure. They involve encryption, and again, that costs you an overhead in time in the transfer. Particularly for scientific data, where the data themselves are not particularly sensitive or may not be particularly sensitive, it may be advantageous to use a non-default cipher in the transfer to reduce the cost of that. And in the ARCHER1 to ARCHER2 section of the ARCHER2 documentation, I think there are some examples of that. So given that we keep those things in mind, here's a little exercise which is just asking you to create. You can do this either on your home machine or make up something on ARCHER2, and it's asking for an uncompressed zip archive. To be created from some directory. So the other thing this exercise is asking you to do, which is a useful exercise, is to verify that you have a well-formed archive. It would be slightly embarrassing to create an archive, delete the original data, and then discover for some reason that your archive file was not corrupted or not well formed or corrupted in some way, and so you'd possibly lose some data. So the question, you may need to consult the man page for zip or tar. You can do it via tar if you so wish. So I'll give you a few seconds to have a go at that. Make sure you can have a go at that. So I'm just going to, for the sake of an exercise, I'm going to create myself some oops, that didn't work, did it? Try that again. Create myself some files, hopefully. So this is just the Git repository for the course with a rather long name. Yeah, it's broken. Okay. So being a tar user, I would do something like the following. C for create, F is the file name argument, so I should have a tar file which is uncompressed. If should I wish to compress it, I might wish to compress like so. If I wanted to do a zip, I'd probably have to look at the man page for zip to do this. Here we go. Where are the? I think zip has a huge number of arguments, doesn't it? Here we go. Okay, somewhere in there, there'll be the the details for what we need and see if I can remember. So I think we need something like -R for recursive, for no compression. From memory, the argument is 0 for 0 compression level. Then you have to give the argument name, the directory you're looking for. I'm going to have to cheat and look at the solution for this. So that's the file argument, and that's the file name for zip. And we should have a zip file there, which is .zip, and to verify this is valid, we would pass in -t. No, is that right? Not correct.
It should be -0R rather than -R0.
Oh, right. It's order matters, of course. Okay, let's get rid of that.
I might be wrong.
So that's given. Should we have a zip file with no compression, apparently? No. Is this correct? So let's do what everybody does. Go to Google. Unzip mine. Is that? Whoops. I'll do that. Oops. Right, there we are. We found an error. Unzip -t. On Archer, at least, to check you have a well-formed archive to check you. Okay, so hopefully everybody can navigate their way through that. Okay, so those are the basic elements of logging in to ARCHER2 and transferring data. Okay, so let's move on, unless there are any questions, to the next section, which is an overview of the ARCHER2 system. So this is really to give you some general information about what the hardware is sitting behind ARCHER2 and how it fits together from the viewpoint of a user of the system. So in terms of architecture, the machine is a Cray machine. The architecture is referred to as Shasta. So it's actually a water-cooled system with pipes running. So it's quite a complex piece of kit. From the user point of view, there's a bit of a picture down below here. We have some login nodes. So this is where we're logged into. When we logged in, we have a login node. So this is UAN01, user access node 01. There are a series of compute nodes where the serious work will be done, which are separate from the login nodes. Sometimes we will fall into the terminology of referring to the login nodes as the front end and the compute nodes as the back end. So that's if I fall into that jargon, hopefully you'll know what I mean. There's also here some data analysis nodes which don't exist at the moment, so please just ignore that for the time being. So for those of you coming from ARCHER1, one important difference in the ARCHER2 system is that both the front end and the back end, or the login nodes and the compute nodes, have the same architecture on ARCHER2. That statement was not true on ARCHER1, which caused a certain amount of pain in dealing with things like compilation and running of code, because the two architectures were not necessarily compatible. On ARCHER2, everything is uniform, so in some senses this is an easier system to deal with. And they're all AMD EPIC processors. There are 64 cores per socket, 2 sockets per node, making 128 physical cores per node. So in picture form, so here we are as users over here on the left. We SSH from our laptop or from our workstation into the login nodes, and when we log in, we land in one of the first of 2 file systems we'll be interested in. This is /home. So over here in my terminal, where I've just logged in, if I do pwd, I'm in my home directory. I'll have a look at a bit more at this full structure in a moment. That lives on /home. So the other file system we'll be interested in for this course is the /work, which is sitting in the middle here. And there is one very important distinction between /home and /work, in that /home is visible only from the login nodes on the left here, while /work is visible from both the login nodes and the compute nodes. So any work which is to be submitted to the back end or the compute nodes via the queue system must live in /work because /home is not visible from the compute nodes. So what's the point, may you ask, of this /home? So this is a relatively small amount of disk space which is backed up for disaster recovery purposes. So if you have critical data which you want to be secure. It should live in /home. So there is about, in total, some 1 petabyte for the whole /home system. In contrast, the /work file system, which is not backed up, is about 15 petabytes. So much bigger. Also in this diagram, you see down at the bottom here, you'll see this solid state storage. This is not available yet, but will be at some point in the future. So this solid state storage, rather than the traditional spinning disks that are /work, this is, as its name suggests, solid state, and so is relatively fast storage in terms of the time it takes to transfer data into the compute nodes. And it may be, in some circumstances, advantageous to hold frequently used data there rather than on /work. Being solid state, it's also relatively expensive in terms of money compared with spinning disk, so there's less of it. But there will be more about that when it becomes available. Okay, so the ultimate plan for ARCHER2 is for there to be some 5,500 compute nodes, which would be a total of about 750,000 cores. At the moment, we only have about 1,000 nodes available, or about 100,000 cores. The remainder are still in the US, but we hope to have a full system available before too much longer, and EPSRC will be no doubt announcing progress on that when it's available. So the existing about 1,000 nodes worth of ARCHER2 is of comparable size to ARCHER1. So what else is here? The nodes, each node has 256 gigabytes of memory. Again, ultimately, there is an intention for there to be a smaller proportion of the nodes with a higher allocation of 512 gigabytes per node. Those are not available yet, so they're all at the moment 256 gigabytes per node. So this, for those of you coming from the existing ARCHER service, this table presents a comparison. So the main differences one sees really are the number of cores per node has increased significantly from 24 to 128. So my view of this from the view of software developer for scientific applications is it's becoming increasingly more important to think about threaded models in programming, be it OpenMP or whatever, because the number of cores one is being faced with means that one MPI task per core is becoming a significant overhead. So one wants to think in terms of shared memory programming. One might worry about these non-uniform memory access regions in the hardware, that is regions which at some level share cache. So on Archer there were 2 NUMA regions per node, each with 12 cores. ARCHER2 there are 8 NUMA regions with 16 cores per NUMA region per node. There's the total memory. Again, all the existing nodes have 256 gigabytes of memory. If one wants to think about that on a per node basis, one could view that as a considerable increase over ARCHER1 if one wants to think in terms of a per core provision of memory. It's actually a decrease because the number of cores has gone up. So an important point for many scientific codes is memory bandwidth. So while headline figures often tend to concentrate on raw performance in terms of delivering operations, which is fundamentally related to the clock speed on the processor. Many scientific applications are actually limited more by memory bandwidth. That is, how fast can I move data between memory and the processor. So that this is quite an important number, and there's the comparison between the two systems. Again, if one is interested in message passing between nodes, then there is some bandwidth associated with the interconnect or the network, which is the largest rate in which I can push data through the network. Okay, so that's some general background. So what do I actually see as a user? So here's this home file system. So this is structured in a particular way. So /home has a subdirectory which is the project. there's another subdirectory which is a sub-project, which by default is the same as the project, and then finally is the user ID. So this for our case today, we're in project TA009. So the project is TA009. The sub-project is also TA009, and this is my user ID. So that looks like that. So that's home directory there, sitting on home file system there. So hopefully everybody's clear in that. As I said, so the home is, you have a certain amount of disk allocation associated with the account in /home. I think you can look that up in SAFE. For organizational purposes, some larger entities may wish to split their projects up into sub-projects. So, for example, project T01 may decide it wants a sub-project T01-RSE, which may contain some subset of users, and they'll have access to that disk space. But generally, most projects will stick to this form. Okay, so home is backed up. So there's also an analogous /work file system, which we can change directory to there. Exactly the same form. So as again, the important point here is when we get to submit jobs, we need to be sitting in /work, so the back end can see the appropriate files. It is possible to have a look at your quota sitting on the machine itself, so you can look at either the quota for the group as a whole or an individual user. So on the work file system, one can have a go at this. So for the group as a whole, the incantation is this LFS quota minus HG for group. Our group is TA009, and the file system is /work. So that tells us on file system work, we've used some 200 megabytes out of a quota of 50 gigabytes for this project. You'll notice there's also a quota in terms of the number of files, not just the amount of space used. This is because there is an overhead in storing the metadata for each individual file itself, so the number of files is actually limited. So these parallel file systems, which is Lustre in the case, is sitting behind /work, tend to work more efficiently if you have, in general, fewer larger files rather than zillions and zillions of small files. So that's the group quota. There's an analogous expression down here for individual user quota, so I can try that one for me. And you can have a go for your. So I am KST009 on /work, and I've used not very much. Okay, so that's just a way to get a snapshot of what the current situation is. As I say, solid state not available yet. When it does arrive, it will be integrated in some way with the scheduler, is how it will be exposed to users, because it's relevant for running jobs. Okay, so those are all those are my directories. The question you may then ask is how could I share some files or some data with perhaps other members of my project, or perhaps with everybody or anybody. To share data within a project, there will be, for every project, automatically available, there will be a shared directory with a path of this form for a given project name. So we should have, we should see, if we do for our project with TA009, TA009 shared. There's nothing there just yet, but we should be able to see that this directory has read, write, execute permission for the owner, but also read, write, and execute permission for the group here. So everybody should be able to see that directory. So if I were to create a file in my own directory, and I wanted to share it with the group or project, I can copy it into that directory there, and you should be able to confirm that you can see that file in the shared space. Not a very interesting file, but that's the principle. So if you want to share data, there's the place to put it. Likewise, if you want to make files or data available to anyone, there is one level up, another of these shared directories which anyone can see. So we have a look at that one. So for us it's TA009 shared. You'll see that this one has not only read-write for the owner and the group, it also has read permission for others, so everybody can see it. So if you moving stuff into those shared directories, you may be it may be necessary just to check that you've got the right permissions on the file. So a change mode of this form, where the minus capital R is recursive if there's a whole directory structure, and the GO plus R capital X incantation means please give the group and others read and execute permission on those files. So that's fairly standard Unix stuff. Okay, any questions arising on this stuff? Okay, somebody's put a tip on arguments to things. Yeah, always useful. Okay, so that's the basic sort of file system setup you use, and how you might think about going to share files with either your own project or others as necessary. So what's available in terms of the software? ARCHER2 is running a version of Linux, and the official, I see here is the word, shell is bash at the point of login. If you use another shell, that may be available, but if you have a problem, you may be on your own. We may try to help, but the official recommendation is to use bash. So in terms of system software, Cray, as well as providing the machine, the hardware, supply this Cray programming environment, which consists of a set of compilers, which can be either based on the GNU compiler collection, Cray compiler, Ensemble, or I can't remember what the E stands for actually, or for this machine, AMD, the AMD optimized compiler collection. Note there's no Intel, not being an Intel based machine. Cray also provide a standard message passing interface based on MPI CH2. Other stuff which you may or may not have heard of, including open shared memory, global arrays, which is a model for doing partitioned global address space type work. If you're interested in such things, standard scientific and numerical libraries, linear algebra, BLAS and LAPAC being the serial and parallel incarnations of that, and BLACS and SCALAPAC being parallel versions are available through the module system, which we'll have a look at later. AMD also offer various libraries. Cray supports a number of standard libraries such as FFTW3, data formats HDF5 and NetCDF. We'll have a look at these in the module system a bit better. Also, for this course, we'll have a look at GDB. On ARCHER2, we were lucky enough to have DDT. The powers that be have decreed that they're not going to spend the money on that, so the fallback is GDB for HPC. Also Valgrind, there's a special version of Valgrind for using on this machine. Profiling we'll have a look at via CrayPat. So for those of you interested in Python, you should at least be cognizant of the fact that Cray provide a standard Python 3 implementation, again through the module system, which we'll see in a moment, which provides optimized NumPy and SciPy, the message passing interface wrapper, MPI for Pi, and Dask, if you're familiar with Dask. Anybody doing R for statistics, there's also a standard R installation. Again, for those of you coming from ARCHER2, the biggest difference is probably the addition of this standard Cray supported Python 3. Note, ARCHER2 will not support Python 2. So Python 3 is the way forward there. As I mentioned, that there's no Intel or Makel, because this is not an Intel machine basically, and there's also no longer available will be DDT or the map, which come under the package which is labeled ARMForge. Okay, so that's the sort of system stuff which comes from Cray and is supported by Cray. There's also a load of stuff which the science and engineering support of the ARCHER team will provide. So this includes standard applications for people wishing to use them. So things like if you're doing quantum chemistry, you'll know about things like CASTEP and VASP and CP2K, LAMPS, GROMACS, etc. or classical molecular dynamics. There's things for engineering and fluid dynamics, things like Code Saturn and OpenFOAM. If anybody's coming from more like system science, MIT GCM is there, and various codes from the Met Office are actually being supported by the Met Office on the machine. We will also provide a series of standard libraries which are not quite available yet, but will become so in the near future. There's also various tools. You might recognize some of these down here. ParaView, for example, for visualization. Plumed is a library for doing enhanced sampling together with molecular dynamics typically. So that's more really a library. Is linked in with one of the materials modeling code. There is some machine learning stuff, for better or for worse, perhaps more typically thought of in terms of GPU machines. It should be said that as part of the ARCHER2 agreement, there was to be what was called a collaboration system, which would have some AMD GPUs, but we're still waiting for further news on that. Yes, okay, so some of you will have noticed that some of these things are in the open source domain and free for use, OpenFOAM, LAMPS, other stuff. Some other things, typically in the quantum chemistry domain, require a license. So for those of you coming from ARCHER1, you'll be familiar that you have to be a member of the appropriate group to be allowed to see the relevant software. So if anybody's needing to access such packages, you need to apply through the SAFE, and you do this by going into the SAFE, finding your appropriate account, which is for me somewhere down. Where is it? Oh, yes, okay, let's use that one. You can click on this request access to package button over here on the left, and you have to find the one you want from the pull down list. So that's VASP 6, so I could check that. For those of you coming from ARCHER1, note, we don't need your license details again if you're already a member of the VASP6 on ARCHER1. But if you're a new user, we would need the details of your license, which we check against the VASP people in Vienna. Okay, one last. So, if the one last point, which may be of interest to some folks, ARCHER2 supports singularity containers. So, if ARCHER2 itself doesn't support the software you want, one possible route to providing yourself this software is to provide it in a container. There are separate course on containers, so if you're interested in that, you can have a think about containers. Okay. So again, this being an online course, you're going to have trouble speaking to your neighbor, or the alternative is perhaps you may wish, if you would like to, just put a couple of sentences into the chat on who you are and what you're doing to introduce yourself. But not mandatory. Not. Okay, so if there are no questions on, hopefully that's all relatively clear. Okay, I'm going to suggest at this point we have a 10-minute break until 12:30, and then we'll come back and have a look at the development environment. Okay, so it's 12:30, and on the schedule, I look a bit behind, but I'm taking a fairly relaxed view of that. We should have plenty of time to cover all the relevant material. So next is the ARCHER2 development environment. So how can I find out what compilers and tools and libraries and so forth are available, and how can I get help in looking at these things. Okay, so hopefully those of you coming from ARCHER1, and indeed everyone, is familiar with the idea of the module system, which is going to provide access to different versions of various software on the system. So the most basic good start command one can try is module list to find out what modules are loaded on the system. So here's a list of modules that are loaded by default when I log in. So I haven't done anything to the module system at the moment, and this is the default list. So there's just a load of modules. So there's this thing, module CPE Cray, compiler environment Cray, which has within it another module related to a specific version of the Cray compilers, and a load of other stuff here. So for example, libfabric is related to the network, as is this Cray PE network OFI, Open Fabric Interface. Here are loaded by default. There are some, there's this perf tools base, which is related to performance analysis, which we'll look at later in the course. There is this Cray MPICH, which is the message passing interface. And there is Cray libsci loaded by default. This provides basic linear algebra, BLAS, LAPACK, BLACS, and SCALAPACK are coming out of there. So those are loaded by default. And then there's a load of, at the bottom here, there's a load of convenience modules set up by the CSE team to allow access to the other relevant software. So that's it. There's some, if you wish to try, I don't recommend doing module purge, but if you're aware of what that does, you can have a go and try and find your way back. But more generally, if one wants to find out what's available in the module system, you can do module avail. So there's a reasonably extensive list of stuff coming under various sections here, you can see. So here's this machine learning stuff I was referring to a moment ago. There's a section broadly utilities, so things like CMake, TCL/TK, if you're familiar with those scripting languages. I'll just make a note at this point, there's this XTHI thing, which we'll be using later as an example, is available via the Q system. Various packages here. So here's CASTEP and all the rest of it in this section. So again, while this stuff is ostensibly available, you must be have a license and have been added to the right group in order to use it. A load of performance analysis stuff here under this perf tools section. We'll see a bit more about this later. There's a whole load of stuff there on huge pages, which I'm not going to go into here. And here's a lot of stuff in opt-Cray provided by Cray. So what have we seen so far? We've seen Cray libsci is loaded by default, actually. There's also available are things like FFTW for Fourier transforms, Here's Cray Python. Here's over here, 3.8.5. So if you want this Python installation, which provides optimized NumPy, SciPy, and MPI for Pi, etc., that's the one to go for. Here's GDB for HPC, which again we'll be using later. So all those things are available. I think, and there's oh yes, okay, here we go. So for each of the compiler environments, there will be associated with it potentially different compiler versions. For the AMD optimizing compiler collection, there happens to be only one, which is this 2.1. For GNU, there are two operational versions, GCC 10.1 and GCC 9.3. GCC 8.1 appears to be there, but I do not recommend using it for reasons I can go into if you're interested. And there's a certain amount of other stuff. So that's the grand overview of what's available. If one wants to be a bit more specific in your search, you can, for example, say what GCC modules are available, and that's the answer. Okay, yes, so if you wish to have a little bit more information, you can query if you know the name of the module, you can get some basic information about what's what by using module help. That will tell you a bit about an overview of what's available there. Note, if you want further, in the specific case of Cray libsci, you can do man intro libsci. Okay, so hopefully that's all relatively familiar. So one place where things do start to differ from ARCHER1 in an important aspect is what is a module, and the issue of what are now referred to as module collections, which we'll address here. So if we wish to, for example, to have Cray Python as an example, so one may ask, where is Python? So try Python 3 on the machine. Note there is a default system version living there in /usr/bin. That can be used, but we don't recommend its use for any production work on the back end. Rather, that we would recommend you use the module version, which is coming from Python. So you can see that has loading that module has adjusted the environment variable, which is the path. So the module version of Python is identified in this case. Likewise, if you want to get rid of it, it's just module unload Cray Python. Here we go. And you should be back to where you were before. Okay. So that's a module. So the other thing we have to think about is potentially wanting to switch between these different compiler environments. So by default, the compiler environment is Cray. So if you were coming from Archer, you might be tempted to do something like, if you wanted, say, you might be tempted to say something like that. I want to use programming environment GNU. Don't do that because you'll get a nasty error. So this these programming environments being programming environment Cray, programming environment GNU, and programming environment AOCC are now what is called module collections, and the appropriate command to change between module collections is this module restore command. So if we issue that, it actually spits out quite a lot of messages. Bottom line here is this module collection is basically a list of individual modules. Module restore goes through the list, unloads the outgoing ones, so unload Cray, libsci, etc., etc., etc. When it's done that, it will load up again the relevant GNU modules. Notice that is a module related to programming environment GNU. And that is the final state. So if we do module list again, we should find we have GNU compiler collection, the default version of. Okay, so again, that's as a little tip, to get rid of that rather verbose restore, you can use the -s option to silence it, like so. So if I wanted to move from programming environment GNU, so programming environment AOCC, I can do that. It's slightly less alarming. And if I do module list, I see I'm now in the relevant modules for AOCC loaded. Okay, so hopefully that is all clear. So there are modules and module collections, and these things, the programming environments are module collections which need to be treated with this restore command. If for a given programming environment one wants to change between specific compiler versions, and this is only actually relevant in programming environment GNU at the moment, we can do that. So we can remind ourselves that available versions of GCC are the following versions, for which GCC 10 is the default. If I wished to use 9.3 instead, I use a traditional module swap command for 9.3.0, for example. And I should have, oh, it's appeared over here. Oh, there you go. It's appeared over. 9.3. And all the other modules which relate to this will make the appropriate adjustments behind the scenes to pick up things related to GCC 9.3. Okay. Actually, so for programming environment AOCC and programming environment Cray, there's only one choice at the moment, so it's not an issue. As I say, one should avoid GCC 8.1.0 for the reason that 8.1.0 may have some incompatibilities with some of the other important modules, such as the MPI. Okay, any questions on this? So the wildcard search, good question. Such a, I'm trying to think of one.
Yes, it is possible to do that. So if you were to do Cray star, should give you a bunch of things.
Yeah, okay, so that's all the Cray stuff. There's anybody doing statistics, there's the R, for example, if you're interested in statistics. Okay, so yeah. As the service goes on, I suspect the number of modules will proliferate, and such specification will become more important. Okay, so that's what's available. We want just for a moment to think about compiling. So for people doing Fortran, C, so whatever compiler environment you live in, where am I at the moment? I'm still in, so I'm still living in programming environment GNU. There is a uniform interface to the compilers to be invoked from the command line, and this is basically CC, small cc for ANSI, capital CC for C++, and FTN for Fortran. When compiling, one should use this form of the compiler in preference to anything else. So the reason for this is that this form will automatically, behind the scenes, work out all the necessary incantations required to, for example, link against MPI and find the appropriate MPI headers. So that makes life easier, and for consistency's sake, you should use this form of the compiler wrapper. So if you want help on a compiler, so if we did man cc, say, you will actually get, as the first choice will be the man page for the wrapper. So the man page is invoke the C compiler for the currently loaded programming environment, and the wrapper has a series of arguments which are distinct from the compiler arguments themselves. So there's an interesting option here, I happen to know, for the wrapper, --cray print opt. So let's give that one a go. If I was to invoke cc --cray print opt, it will actually tell me what it's really doing, i.e. the compilation and link options it is issuing. So it knows, for example, it needs to include from the appropriate location header files for MPICH for this particular compiler environment. Likewise for this libsci include, that's for the BLAS and LAPACK, etc. Likewise, the appropriate link time incantations are included for you. So that's what's going on behind the scenes through the compiler wrapper. So you should use that, and then that will forward any additional arguments which you want to specify for optimization and so forth to the true compiler, or the specific instance of the compiler that which in this case will be GCC doing the work behind the scenes. Okay, so that saves you from having to explicitly do things like specify all these various libraries on the command line. Okay, so a word on linking. All link stage which will gather together object files and libraries and create an executable is done dynamically on ARCHER2, which is in contrast to ARCHER1. So you may want to start to think about those things you think about when having dynamic libraries in play, like do I care about LD library paths at runtime and whatever. Okay, so one useful option there is, it's probably worth noting, is that you can, if you want to get the compiler wrapper to stick the library location into the executable via the rpath mechanism, you can do that. There may be pros and cons to doing that, but that's available. Most of the stuff that's available, most of the applications do depend upon an LD library path at runtime, and so it's maybe necessary to load the appropriate module, not only to locate the executable, to make sure any dynamic libraries are located through LD library path. Okay, so there's more on various compiler type stuff in the documentation. Certainly, if you have any questions, perhaps if you have a chance to tomorrow to have a go at compiling your own stuff or whatever you want to do, we can look more closely. But the main thing to remember is this one. Use the wrappers. Historically, some build systems for software had an annoying habit of squirreling away deep in their structure specific references to things like GCC, which could often break. My feeling is that packages are now getting a bit less fragile in that respect, and behave more robustly. Incidentally, this thing lmod modules is incorrect. That should be, this is standard environment modules. Okay, how are we doing? Right, okay. I'm not going to do any more before lunch, so I'm going to, unless there are any questions arising, so I'm going to suggest we come back at 2 o'clock, 1400 hours GMT, and we'll have a look, I'll get into the meat of the course by having a go at submitting some jobs, which again is a little different from ARCHER1. Okay, so we will break until 2 o'clock.